A planet was discovered by mathematics so convincingly that half the scientific world spent more than 50 years trying to see something that did not exist. In 1859, Urbain Le Verrier, one of the most respected astronomers on Earth, published what looked like an impossible conclusion. Something invisible was pulling on the orbit of Mercury. The numbers were clear, the calculations worked, and according to the most trusted laws in science, there had to be another planet hiding closer to the Sun. There was only one problem. The planet was not there. But nobody believed that yet, because Le Verrier had already done this once before. Just years earlier, he had mathematically predicted the existence of Neptune before anyone had ever seen it. Telescopes pointed exactly where his equations said they should, and Neptune appeared. So when he announced another hidden world orbiting inside Mercury's path, the scientific establishment did not hesitate. The new planet already had a name: Vulcan. And from that moment forward, astronomy began one of the strangest collective mistakes in scientific history. The problem started with Mercury itself. For centuries, astronomers had tracked its orbit around the Sun with extreme precision. According to the equations developed by Isaac Newton, Mercury should move in a perfectly predictable path. But it did not. Every orbit drifted slightly, tiny amounts, just enough to create panic among people who understood what those equations represented. Newtonian physics was not simply another theory. It was the machine running all modern science. It explained falling apples, planetary motion, artillery trajectories, ocean tides, engineering calculations, everything. And Mercury was refusing to obey it. That meant astronomers had only two choices. Either Newton was wrong, or something unseen was interfering with Mercury. No one was ready for the first option. So Vulcan became the answer. And suddenly, telescopes everywhere turned toward the Sun. Victorian observatories began hunting for a planet nobody had ever seen directly. The method seemed simple. Wait for Vulcan to pass between Earth and the Sun. A tiny black dot would cross the bright solar disk. Proof. And soon, something unsettling began happening. People started seeing it. Across Europe, respected astronomers reported dark circular objects moving across the Sun's surface. Each observation seemed to confirm Le Verrier's prediction. A black speck here. Another transit there. Different observatories. Different dates. Different witnesses. Each one treated as evidence. And with every report, Vulcan became more real. But that was where reality first began separating from expectation. Because none of the sightings matched. Not one. Orbital calculations based on one observation would fail when compared against the next. Some sightings suggested one orbital period. Others suggested completely different trajectories. Astronomers adjusted the numbers. Again. And again. And again. Each failed prediction created a new version of Vulcan. Yet nobody stopped to ask the more dangerous question. Why was every piece of evidence contradicting every other piece of evidence? Because by now, the cost of being wrong had become too large. The scientific community was no longer searching for a planet. It was defending Newton himself. The tiny black dots crossing the sun had become something bigger than observation. They had become institutional survival. And that changed how people looked through telescopes. The same solar image returned again and again. Astronomers staring directly into blinding sunlight through fragile 19th century instruments. Small distortions flickered constantly. Lens imperfections. Atmospheric turbulence. Floating debris. Optical noise. But now every shadow carried meaning. Every dark speck became possible proof. And slowly, something dangerous happened. Expectation began manufacturing evidence. Thousands believed they were observing Vulcan. Not because they were dishonest, because they were trained to expect it. The telescope had stopped being a neutral instrument. And that is where the real damage began. For decades, scientific journals accepted Vulcan as probable reality. Textbooks referenced its existence. Orbital models included it. Observatories kept searching. Entire careers formed around refining calculations for an object that could never be confirmed twice. The same image repeated over generations. A Victorian astronomer staring into solar glare, waiting for a black dot, believing they had found a world. But the longer Vulcan survived, the more dangerous the situation became. Because Mercury kept disobeying Newton. Even after 50 years of searching, no stable orbit for Vulcan could ever explain the anomaly completely. The prediction worked. Reality refused to cooperate. And then everything changed in 1915. A young physicist named Albert Einstein introduced a theory so radical it erased Vulcan instantly. General Relativity showed that Mercury's orbit was not being disturbed by a hidden planet. Space itself near the sun was warped. Gravity was bending geometry. Newton had not completely failed. But his equations were incomplete. Mercury had been telling astronomers the truth for half a century. They simply refused to hear it. And suddenly, every black dot ever seen crossing the sun changed meaning. Not evidence. Not discovery. Not proof. Just generations of brilliant scientists watching exactly what they expected to see. That is the part people forget about science. Science does not collapse when information is missing. It collapses when too many people become committed to protecting the answer they already trust. For 50 years, the world's best astronomers searched for a planet created entirely by belief. Vulcan never existed. But everyone saw it anyway. Sometimes the eye obeys belief first.